Okay, so I am making a recording explaining worksheet 8.1 WSP, not all of them, but just some of them. Now, the number one thing to remember on this section is that you're gonna go through and try to factor anything possible. And the reason why we factor is to get multiplication, and then once you have multiplication, you could cancel things out. So on number one, I already did number one. It's ridiculously easy because it's already all pure multiplication. You could just start canceling things out. 9 and 27 cancels out. There's a 3 left over on the bottom. There's two A's that cancel with 2 of the 4. You have 2 left over on the bottom, and so on and so on. But there's going to be some where you actually have to factor first, right? Like number 3, for example. Let's factor something out of the top, and then also factor something out of the bottom. Okay, so always try to pull out the GCF first. On the top, we could pull out the multiple of 5 as well as the variable y from each term. So when you do this factoring of GCF, 5 times what gets you a 10, 5 times 2. And then y times what will get you a y squared, a y. So you end up with a 2y right there. And over here, you end up with 5y times what will get you that positive 15y. That'll be a 3. So we have factored out a 5y. What do we have left over? A 2y plus 3. If you factor it right above the way I just did, you might want to put a line through it just so you don't get confused. You have the above factored form representation of the numerator 10y squared plus 15y. So I'm not even going to worry about the 10y squared plus 15y anymore because I already factored it. Same for the bottom. I could pull out a 5 and also a y. And what will I have left? 5 times 7 with a y will give me the above, 5y times 7y will give me the above 35y squared, and 5y times negative 1 will get us that negative 5y. So again, I'm going to put a line through this so I don't get confused. I've already rewritten it as the below factored form. Now that I've factored, now I truly have something times something else, which is a binomial, and on the bottom we have something times another binomial. So because we have this pure multiplication, we are now able to cancel out the like terms. The 5y cancels out with the 5y, and this is your answer. 2y plus 3 over 7y minus 1. That is your answer. Let's move on. Now, obviously, it gets way more complicated than that. Let's take a look at number 5. That's a little bit more fun. Now, why do I say it's more fun? Because in the numerator, I noticed something weird. They have the constant first, right? They have the 25 first instead of the variable v squared. It's not organized. So what I would like to do is organize it first before anything. So I am going to take the v squared, but it's technically a negative, and I am going to put it out here in the front of this positive 25. So I really have a negative v squared plus 25. I hope that makes sense. So since I moved it already, I'm just going to scratch it out. There's my new, more organized numerator, negative v squared plus 25. I might as well erase this arrow. And I hope we all understand that this right here, you could factor something out of that, okay? Even though you can't pull out a v or you can't pull out a 5, you could pull out a negative 1. And what would be left over on the inside if you pull out a negative 1? Well, you'd pretty much be changing the signs, and you'll have a positive v squared minus 25 now left over on the inside. Does everybody understand that? Okay, great. So I pulled out a negative 1, and now on the inside of the parenthesis, okay, on the inside of the parenthesis, something else is ringing a bell. That's a v squared minus 25. Technically, that's a difference of 2 squares. I could, in fact, well, let me rewrite the negative 1 up here. I could, in fact, do the square root of the v squared, the square root of the 25, and put it in my factored form answer format, v plus 5, v minus 5. Or you could think of it the old school way. What times what is negative 25 that if you combine together is a middle term, which means nothing because there is no middle term. And that would obviously be a positive 5 and a negative 5. So you have the v, you have the v. What times what is negative 25? That combines together to give you nothing, a negative 5 and a positive 5. So a lot happened on that first numerator that it kind of looked like we weren't able to do anything with it, but once we switched it into the correct order and pulled out a negative 1, then we started noticing other things that we could continue doing. So that numerator really did become this guy up here, okay? So I could put a line through everything else. That's what we have as the numerator. Now in the denominator, it's even more fun. Why? Because we have a 3 right here. That just messes, I mean, it doesn't mess things up, but it does require a lot of work when your A value is not 1, right? We have to go through that multi-step process. Step 1 is to multiply A times C. A times C will give us negative 30. Step 2 is to think of the multiples of negative 30. Let's make a list. Negative 1 times 30, negative 2 times 15, negative 3 times 10, negative 4 doesn't work, negative 5 times 6. Those are all the possible ways of multiplying numbers together to give us negative 30 besides changing signs. So let's now start combining and seeing which of those pair of numbers combines together to give us this middle value, negative 13, okay? So if I combine 30 and negative 1, that'll give me 29, not negative 13, so that pair of numbers doesn't work. If I combine 15 and negative 2, if I combine that, that'll give me a positive 13. And that is the number that I want, but I want it to be negative. And when I combine these, I end up with a positive 13. So I have the right number, just the wrong sign, which means I have the right numbers, just the wrong signs. Make this a positive 2, make that a negative 15, and now you'll be ready to do step 3. Now step 3 depends which path you take. You could convert the trinomial to a polynomial, to a 4-term polynomial, by replacing the negative 13v with positive 2v minus 15v, getting 4 terms so you could factor by grouping. I wouldn't do that. There's a shortcut. What is the shortcut? I hope we remember that the shortcut is to already do your parentheses, like your factored form format, and simply write whatever you see as your first term, but without the square, write it twice, okay? I hope we remember that. Write the 3v without the square, write it twice. So write it here, 3v and 3v, okay? And then take the pair of numbers from step 2 and plug the positive 2 right there and the negative 15 right there. So we have a positive 2 right there and a negative 15 right there. And now for the 4th magical step is to reduce anything possible. Now, I shouldn't even say reduce, just magically divide each binomial by whatever you can. And if you can't, just rewrite it. So the 3v, this first one right here, 3v plus 2, you can't divide it by anything, so just rewrite it, 3v plus 2. And the second binomial, you could divide both terms by 3, and that'll leave you a 1v minus 5. So that was a large process, a large multi-step process to get to the factored form of this guy that was below, okay? So it's kind of ugly right now. Let me rewrite everything. I'm going to rewrite it, the negative 1, parenthesis, v minus 5, close parenthesis, open parenthesis, v plus 5, close parenthesis, over the 3v plus 2 times v minus 5, okay? So this is what we have so far. Let's now cancel, since we already factored and it's all pure multiplication, let's cancel anything possible, which will be the v minus 5 up here with that v minus 5 down there. And what else cancels? Nothing. So that's your answer, right? Let's write our answer. Our final answer will be negative 1 over, actually negative 1 times v plus 5 over 3v plus 2. And you don't need the 3v plus 2 in parentheses because there's nothing else with it down there. So you can just leave it like that. This is your answer. Another possible answer would be to take that negative 1 and distribute it into both the v and the 5, which would give you a negative v minus 5. Or even another possible answer is to simply take that negative and put it out here in front of the parenthesis. That way you could leave the v plus 5 and the 3v plus 2 on the bottom. So this is another acceptable answer. But of course, this is totally fine. Let me pause this for a second. Let's move on. That was fun. I know you guys are like thinking, man, all this entertainment for free. Number 10. Yeah, what the heck? Where are the numbers at? Bunch of letters. Is this the alphabet? Okay. What's step 1, or what do we do when we're trying to simplify these rational expressions? We're trying to factor and then cancel. right? Factor and then cancel. Right now, I can't factor this, I can't factor that. I look at this guy and I'm like, wait a minute, this minus sign with two perfect square terms, that's telling me something. That is a difference of two squares. I could take the square root of that, take the square root of that, and plug it into my factored form answer format with a plus and with a minus. So let me do that right above. I want to put parenthesis. We know that the square root of w squared is w. We know that the square root of n is n. So I put a w and an n, I put a w and an n, and of course one has to be plus, one has to be minus. And that's it. That's the only type of factoring I could do right now. But when I look at this denominator and I see the y minus a, well, first of all, up here I have an a minus y, and down here I have a y minus a. That's weird. It'd be nice to have them organized in the same manner. So let's switch the order. Let's take this negative a and let's write it out here as a negative a in front of that positive y. I hope that makes sense. I have moved the negative a to the front. Now, at least it's more organized. At least it's starting to look like this guy, a minus y, but down here it says negative a plus y. So a minus y, negative a plus y. What the heck? This a is the opposite of that, and this y is the opposite of that. In other words, all I need to do is factor out a negative 1 from that denominator, pull out a negative 1, and I will have a positive a and a negative y left over on the inside. And as you could see, now that we have factored everything possible, we could cancel this entire binomial, a minus y, with that entire binomial, a minus y, cancels out. We could also cancel out this w plus n with this w plus n, cancels out. What's left? We have the final answer, w minus n over a negative 1. This is a perfectly acceptable answer. But let's talk about other possible answers, especially because we're dealing with a lot of multiple choice questions. If you don't see that exact answer, it could be written as w minus n with the negative 1 out here in the front. But then again, if we did have that negative 1 out there in the front, you might as well distribute it. So that would be a negative w plus n. Okay, so maybe I shouldn't have even done this work right here. That's ridiculous. It's as simple as this. When you have this answer right here, we know that dividing by negative 1, all it does is change the sign. So yeah, that w divided by negative 1 is a negative w. That negative n divided by negative 1 is a positive n. So here's another perfectly acceptable answer. Okay, so yes, this is right. That's absolutely 100% correct. But if you're looking for that on the multiple choice and you don't see it, it might be written like this. Shoot. Let me even tell you another possibility that it might be written. It might be written like this. It just looks nicer, right? When you have an n minus w as opposed to a negative w plus n. So all of these three answers are perfectly fine. This one's good, this one's good, this one's good, right? You got to be able to understand which answer it is on the multiple choice problems. Looking at number 11. See, on many of these that we've selected to do, we have this funkiness where it's out of order, where you have to rewrite it in order. I like that. It's pretty cool. When we look at this top quadratic trinomial, and we think what times what is negative 24 that if I combine together is negative 5, you might want to make a list. Negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6. Those are all the possible ways of multiplying numbers together to give you negative 24. And if you combine them together, which one gives us the middle value, negative 5? That will be negative 3 plus 8. That'll give us a positive 5, but we want a negative 5. We have the right number, just the wrong sign, which means we have the right numbers right here, just the wrong signs. So please change that minus 3 to a plus 3, change that positive 8 to a negative 8, and plug in those values, a positive 3 and a negative 8. We have factored the first numerator. Let's factor the first fraction's denominator. So what could I pull out of both terms? I could pull out a 2 and an x. And what will be left over on the inside? We'll have a 3 and a x. And you know what? I probably should have switched the order right there. But even still, on the inside, we have a 3 and an x, and I could easily take this x and write it first in front of the positive 3. So I might as well do that right now to get it in order. 2x, parenthesis, we'll have a positive x with a positive 3. Now, why would I do that? Because now this x plus 3 is ready to rock with that top x plus 3. I'm going to be able to cancel those out in a couple of seconds. Let's look at the second fraction. We've already factored everything possible on the first fraction. Let me put some lines through these guys because I've already rewritten it. And in the second fraction, there's obviously nothing to cancel here, but down here, the 8 minus x, I could rewrite that. I will rewrite that. I'm going to write this x term first, this negative x. I'm going to put it first in front of that positive 8. So this minus x is no longer there. I moved that minus x to the front. So it now says negative x plus 8. And I know that I could factor something out of that negative x plus 8 to make it look nicer. I could factor a negative 1, and that will give me a positive x minus 8. All right, I have factored everything possible. Okay, I have this factored form as a numerator. I have this factored form and organized in the denominator. There was nothing to do with that numerator, and we've already factored out a negative 1 after organizing it on the second fraction's denominator. Now let's cancel things out. We could cancel out the x plus 3 up here with this x plus 3 down there. We could also cancel out this x minus 8 up here with that x minus 8 down there. And we could also cancel out, we have a 2x right here. That's really a 2 times x. I could cancel out this x with one of these 2. So it'll cancel and you have 1 left over up there. So I'm going to scratch this one out because it just canceled. Again, this single x canceled with one of these 2. So now I only have 1 x left over on the top. I don't have any left over down here. So this is really ugly. Let's rewrite what we have left over, okay? So up on top, we have a 5 and an x. Let me write that, 5 and an x. There's nothing else. On the bottom, we have a 2. And we also have times negative 1. So your final answer will be 5 over negative 2. That's your final answer. Or you could write it as 5 halves with the negative out in the front. That's totally acceptable and equally correct. Good answer, good answer. So if we take a look at the next part of the PDF of the homework, we have division of fractions, but it's the same exact thing. All you have to do is take the division, change it to multiplication, and flip the second fraction, and then you go about doing the same business as always, right? I'm not sure if, should I do this one? Or what do you guys think? Might as well, we're already here. So right here, as I move this one from the bottom up to the top, as I move it up, I might as well factor. I hope that doesn't confuse anybody. But as I move this guy up, I'm going to factor it, pull out a 4, and I will have an x plus 3 left over. And now it'll be as the numerator, not the denominator of this second fraction. As I move this guy down to the denominator, I'm going to pull out the GCF, which would be a 6x in both. So I'm going to pull out a 6x in both, from both, and I will have x plus 2 left over. X plus 2 left over. Now the first fraction is definitely not going to flip. I'm just going to rewrite it. But as I'm rewriting it, I might as well factor. What could I pull out of that first binomial? I could pull out a 3. What will be left over? I'll have an x plus 2. On the bottom one, I have a difference of 2 squares. I could think what times what is negative 9, that if I combine together is a middle value, which is nothing. That'll be a plus 3 and a minus 3. Everything's factored. Everything's multiplication. Let's cancel some things out. The x plus 2 up here cancels with the x plus 2 down there. The x plus 3 down here cancels with the x plus 3 up there. We could even go as far to cancel this 3 with the 6, right? 3, 6, if you reduce both of them by 3. 3 divided by 3 is 1. You could put a 1 there if you want. 6 divided by 3 is 2. You now have a 2 down there, okay? And then after that, you still could reduce the 4 over the 2. 4 divided by 2 is 2, right? 2 divided by 2 is 1. You can put a 1, you don't have to. 4 divided by 2 is 2. I hope we understand what we just did. Let's see what we have left over. We have the fraction, and up on top, we have a 1. We don't need to write it, times 2, right? 1 times 2 is still 2, so there's a 2 left over up on top. On the bottom, we have the binomial x minus 3. And the question is, do I need to write it in parentheses, x minus 3? If there's nothing else, I don't need to write it in parentheses. But there is a times 1, which doesn't change it, but there is a times x. So I definitely need those parentheses because I will also have an x on the outside of the parentheses. There is my answer. 2 over x times x minus 3. Another acceptable answer would be 2 over x squared minus 3x, but I would prefer you leave it in factored form. Now, let's get finally to the complex rational expressions. I don't know, pick one, 19, 20, or 21. All right, 20 and 21, check it out. What's confusing about this? Probably just the way it looks, because you have a fraction in the numerator and a fraction in the denominator. So first thing I do is I emphasize that division bar, okay? That way when I write it horizontally instead of vertically, x squared minus 9 over 4, and instead of that big giant red division bar, I want to put the division symbol and write it out horizontally instead of vertically. So I have a 3 minus x over 8. So let's understand that, guys, that this is really just rewritten as this. This is vertically, it's written this divided by this. Same exact thing, just written horizontally, this divided by this. Same exact problem. All we're doing is rewriting it. And why are we rewriting it like this? Because we're used to taking this division, changing it to multiplication, taking that second fraction and flipping it. Now, as I flip it, I might as well do some tricks. The 8 really does go to the top. Now that 3 minus x, that's weird. I'm supposed to have my x first. So I might as well write the negative x first and the positive 3 second. Now that first fraction, you know what, just so nobody gets confused, I'm just gonna bring it down. X squared minus 9. We all know that we're gonna be able to factor x squared minus 9, and 4 is 4. So let's do what we're supposed to do, which is factor everything possible and then cancel. So looking at my first fraction, the x squared minus 9, that could become x plus 3, x minus 3 when we factor, right? What times what is a negative 9? That if you combine together is a middle value, which is nothing. That'd be a positive 3 and a negative 3. It is over 4. It is being multiplied by that 8 up on top, which I will be able to cancel with the 4 in a couple of seconds. Now that bottom denominator, the negative x plus 3, that's kind of throwing me off because up here I have a positive x plus 3 and a positive x minus 3. So let's make this positive by factoring out a negative 1. If you factor out a negative 1, you will have a positive x minus 3 left over on the bottom. Now everything's factored, everything's organized, everything has multiplication. Let's cancel some things out. I'm going to cancel the x minus 3 up here with this x minus 3 down there. I'm also going to cancel the 8 and the 4. 8 divided by 4 is 2, which is left over up on top. So what is our answer here? We have a nice beautiful 2 up on top, and we have the binomial x plus 3 up on top, all over negative 1. This is the correct answer. Now, if you look for this answer on multiple choice, it might not look like that. It might look like this, negative 2 parenthesis x plus 3. Why? Because if you say 2 divided by negative 1, that becomes negative 2, which also could be written as a final answer of negative 2x minus 6. So all of these answers are acceptable. So, I don't know. Who wants some of this? Fun stuff. This question, I love it. Let's first start by emphasizing that division bar. We have a fraction in the numerator divided by a fraction in the denominator. Let's write it horizontally instead of vertically, okay? So I have x to the third plus 2 to the third over x squared minus 2x. And it will be divided by the fraction x plus 2 to the third power over x squared plus 4x plus 4. So of course we're going to change the division to multiplication, rewrite that second fraction, but it being flipped. Now, let me take this top one, x plus 2 to the third power, and let me write it on the bottom, but I am going to expand it. X plus 2 times x plus 2 times x plus 2. I mean, that's what x plus 2 to the third power actually means anyway. Just write it 3 times and multiply it with itself 3 times. Now this bottom one, x squared plus 4x plus 4, that could be rewritten as what times what is 4, that if you combine together is 4, that'd be a plus 2 and a plus 2. So that's beautiful because you're going to end up canceling this binomial with that one, this one with that one. It becomes a nice, beautiful fraction. Let's go to that first fraction. And here is where it gets ridiculously fun. Here's the first fraction. There's the times right there between them. Now, why the heck would they write it as x to the third plus 2 to the third? Why wouldn't they just write it as x to the third plus 8? Because they want to point you in a certain direction of factoring. And you might have to dig deep in your brain to remember this. It's a sum of 2 cubes formula. Do you guys remember the sum of 2 cubes formula? It goes something like this. A cubed plus b cubed, and that's exactly what we have here, but instead of a, we have an x, and instead of b, we have a 2. But it ends up being a binomial times a trinomial, where your first binomial is the same exact thing without the cubes, a plus b, and then on the trinomial, you have a squared, and if you add a plus on the first binomial, it's going to be a minus ab, and then plus b squared. I hope you remember this. So I am going to factor this guy up here as I bring it down, and it will be a binomial times a trinomial, okay? So what is the first binomial? It's x plus 2. What is the trinomial? It's x squared, and then we have minus ab, minus x and 2. So that's really going to be a minus 2x. I apologize, I'm doing a lot of these steps in my mind as I apply this formula. Hopefully you're following me. And then at the very end I have a plus b squared, which is going to be plus 2 squared, but I already might as well make it a 4, okay? Because 2 squared is 4. In the denominator, I could pull out on this guy, I could pull out an x. So let me do that. Put parentheses there, pull out an x. What do I have left? X minus 2. Ladies and people, men, everything's factored. Let's cancel everything possible. We have an x plus 2 up here that cancels with an x plus 2 down here. We have an x plus 2 up here that cancels with the x plus 2 down there. We have an x plus 2 up here that cancels with the x plus 2 down there. It's fun when you cancel. What's left over? Exactly this, x squared minus 2x plus 4 over, now I don't have to put this in parentheses because there's nothing left over else up on top. If there would have been like a 5 out here or an x plus 2, yeah, I'd have to put this in parentheses. But since there's nothing else, I don't need parentheses. On the bottom, I truly do have the x times x minus 2. That's my final answer. We're done. Now, even if you tried to factor further, like what times what is 4, that if you add together is negative 2, it can't be done. It doesn't work. That's as far as you could go. Can't cancel out anything else. We're done.